Okay, so stopping distance is actually quite an interesting one. So basically, how we figure out stopping distance is okay. So if I'm driving, right, I cannot just immediately stop because when I push the brakes, it takes a moment for the car to slow down. Why is that?
Because you have a lot of momentum. If the car were to hit, it would be dead.
Dead. It would be like going into a wall.
Yeah,
Okay. So we don't want the car to stop immediately, but we do want the car to stop quickly. And so like it's the difference between someone braking slowly and someone braking quickly. It still does have an impact, but because of the inertia, because inertia says the rule of inertia says that when we are moving in one direction, in order to stop moving in that direction, we have to have an equal and opposite force act against us. Now, if I am moving at 120 kilometers an hour on in the car is moving 120 kilometers an hour, but so am I because I'm also moving because I'm in the car. So if I want to stop moving, I need an equal and opposite force to act against me. So basically, I will be hit with 120 kilometers an hour stopping force. Okay, so that needs to be split up a little bit so that we don't die. Okay.
Yeah.
So other things that can play a role. So we've got the speed of the car, we've got the reaction time of the driver because it takes me a moment to like actually hit the brakes, right? Um, but and the reaction time can be increased by I might be tired, I might be distracted. Like if I'm on my phone, I'm not on my phone anymore because I found a great spot in my car for my phone. I put it in front of the speedometer because who cares about going over the speed limit? I'm joking. My car beeps if I go over the speed limit. It goes beep, beep, beep. It's really irritating. So I can't break the speed limit. But also on my phone, there is a speedometer on the map. Okay. But so that might be a distraction. But also, my kids could be talking to me in the back, and like Bathan could like have a bee in his hair or something. I don't know. Um, I might also be intoxicated, which could be alcohol. Which this is not what I do. It could be drugs. Oh, my dad was like, "So are you going hunting with us? Are you going with your uncle and I, or are you going with your brother?" I'm like, the thing is, my brother sometimes drinks and drives, and I am not willing to be in the car with someone who takes for a long trip takes risks like that. That's not an acceptable risk. So I just don't drive with my older brother. Like I'll drive short distances, but I'm not driving 600 kilometers. That's just like a hard no. Anyway, I'm like my dad was in the police. He saw lots of accidents, so he's like a very cautious, even though he zones out sometimes. But and then my mom was like still not happy. I'm like, do you really want to lose all three of your kids at once? So like, just split us up 2-2. You're fine. So anyway, so intoxication could be a thing, but this could also be like painkillers. Maybe you've got a headache. All of these things can play a role in how long it takes you to brake. So in terms of braking distance, it's defined as the distance traveled under the braking force in meters. So after I hit the brakes, how long does it take for the car to stop? Okay. So there is a thinking distance and a braking distance that we split things into. So if I'm driving 32 kilometers an hour, okay, then that's about. So if I'm driving 20 kilometers an hour, it's going to take me about um, 6 meters to react.
Yeah.
And it's going to take about 6 meters for the car to come to a stop. Okay. Now, if I'm driving 48 kilometers an hour, it's going to take me about 9 meters to react, and it will take about 14 meters for the car to come to a stop. So that's 6 car lengths. That's how long it will take for the car to stop. If I'm driving 60 kilometers an hour, 64 kilometers an hour, it will take me 12 minutes to react and 12 meters to react and 24 meters for the car to come to a stop. So that's 9 car lengths. So if I want to like be absolutely accident free, 9 car lengths is what I need if I'm driving 60 kilometers an hour. That's really intense. Okay?
Yeah.
If I'm going 80 kilometers an hour, okay, I've got 15 meters to react. It takes me 15 meters to react. It will take 38 meters for the car to come to a stop. And so, do you see how it's kind of building up like that? Okay, so I've got 6, 9, 12, 15, 18, 21. Okay, then my braking distance is 6, 14, 24, 38, 55, 75. So even though my reaction time stays low, the faster I go, the longer it takes for the car to come to a stop. Okay? So I can almost draw it like on a graph, right?
Yes.
Okay. So other things that could affect the stopping distance. So my reaction time is affected by a couple of things. The stopping distance could be affected by the speed that the vehicle was going. The vehicle's mass. The heavier the car is, the longer it's going to take to brake, right? The road conditions. If it's snowing, it's going to be a little bit more difficult. Okay? And then obviously your driver reaction time. Okay. So from there, totally different topic. Okay? We're looking at terminal velocity. Now, terminal velocity is basically when you're falling at the sky, there is a max speed that you can go. Okay? Basically, it's when the upward and downward forces are balanced. Okay? So that means that the resultant force on the object is actually 0. Okay? So the object ends up not going any faster. So when I'm skydiving, I've got the air resistance and I've got my weight. So my weight is my mass times gravity, right? My air resistance is what it is. So there's a point where my air resistance becomes equal and opposite to my weight. At that point, I no longer accelerate, but I travel at a constant velocity. That is my terminal velocity. Okay. So I'm going to give you this quick worked example. I want you to do it before looking at the answers. The answers are literally at the bottom of what I have to say. Okay?